Your muscle tension signals your internal organs to change. We think exercise is just about getting stronger. It is actually a precise endocrine dialogue happening between tiny fibers in your limbs and distant tissues like your liver. What if the exact type of muscle fiber you recruit, type I versus type II, acts as a metabolic master switch, releasing specific signaling molecules called myokines? These are not just localized benefits. They are messages that travel through your bloodstream to optimize inflammation control or sharpen insulin sensitivity across your entire system. This is about designing movement protocols based on cellular instructions, not simply accumulating reps. Analyzing these metabolic messages reveals a fascinating feedback loop involving your nervous system. It shows that contractile force does not just send signals out. It actively shapes them internally. Specific exertion patterns modulate vagal efferent activity, meaning controlled movement shifts the balance between sympathetic drive and calming parasympathetic responses in real time. This autonomic crosstalk is crucial because myokine receptors respond differently depending on whether your body is stressed or regulated by that deep flow state we discussed earlier. We are seeing evidence of how precision training can optimize this entire systemic dialogue. But the endocrine dialogue does not end when you stop moving. The actual benefit depends on receptor sensitivity, which changes rapidly after exertion. Think about that window immediately following heavy work. It is a delicate physiological moment. If your system remains locked in sympathetic overdrive, those beneficial myokine signals, the messages we discussed, may not be received efficiently by distal tissues like the liver or fat cells. We are seeing data suggesting that purposefully engaging controlled parasympathetic activation right after contraction maximizes this signal uptake. This shift toward focused internal regulation during recovery is where metabolic efficiency takes off. It requires mapping specific activity inputs to precise post-exercise physiological windows, moving training from brute force endurance into an exercise in timing and cellular reception. The mechanics shift when we examine the moment of contraction itself. It is not enough just to optimize recovery windows. Research shows that specific fiber recruitment patterns are fundamentally reprogramming your internal architecture while you move. Certain movements dictate whether mitochondrial biogenesis gets activated, triggering unique myokine cascades far beyond simple strength gains. This is an immediate autonomic crosstalk event. Contractile force actively modulates the balance between sympathetic stress and parasympathetic calm inside your body as it happens. How did evolution design a system that requires this level of precise metabolic tuning? If we can control these real-time feedback loops, what untapped internal resources are waiting to be activated next? If we look closely at those triggered myokine cascades, they do not just boost energy efficiency. They actually influence fundamental cellular lifespan metrics. Research is showing that specific recruitment patterns can impact intrinsic tissue decay rates by over 40% in targeted organ systems. Yet the exact dosage and timing needed to trigger this full effect remain unclear. This is not simply improving fitness scores or lowering baseline inflammation. It speaks directly to reprogramming the clock of your major metabolic organs. We are observing a potential mechanism for altering cellular aging pathways through movement structure alone. But how do you translate that microscopic deep cellular recalibration into a usable protocol? What happens at this molecular level is far more intricate than merely slowing decline. These cellular recalibrations are not passive maintenance. They involve the body actively reprogramming its metabolic hierarchy. The signals we observe from controlled contraction patterns do not just signal tissue health. They initiate fundamental shifts in how your entire system manages scarce energy resources across competing internal demands. This means that attaining profound somatic coherence sometimes requires a deliberate and intense reallocation of priorities away from perceived stability or short-term comfort. It necessitates suppressing certain systemic responses to allow the deepest repair mechanisms to engage fully, leading toward physiological states with consequences we are only beginning to quantify. The verdict from this research is clear. Metabolic efficiency stops being about simply exerting force. It becomes an exercise in precise physiological input mapping. You must transition your training paradigm away from general volume toward targeted movement patterns that trigger specific myokine cascades and maximize receptor reception at the critical timing windows we discussed. This disciplined calibration of cellular instruction to physical output dictates systemic longevity, not mere fitness score improvement. To see the entire archive supporting this mechanism shift, visit jmthomasofficial.com. The science here provides a clear exit ramp from general endurance training toward targeted systemic mastery. Instead of asking how much you can lift, start by mapping the exact movement required to activate those specific myokine cascades we discussed earlier. This is your primary actionable lever for metabolic programming. Understanding the timing and type of input allows you to deliberately engineer optimal physiological output, moving beyond passive adaptation into active cellular instruction. If you want the complete archive that maps out these precise physical inputs against systemic responses, visit jmthomasofficial.com.